Hello everyone, in this video we will be going to see how we can build a custom NER pipeline. In the previous video we have already seen how to build a normal NER model. So let us start doing it. First of all, I am taking a financial domain dataset. That dataset I am going to totally create from scratch. Let me show you how you can do that. So this is the prompt that I am using in order to create my dataset. So create me 50 example on the financial domain and I want to train my BERT model for custom NER. Generate me the simple dataset in this format and the dataset format is biotagging format. So let me copy this out. Go to ChatGPT. Throw the prompt. Now I'll give some sample data here. And paste it here. Now what it will do, it will create me 50 such example. You can see it is creating me 50 such example. After this, what I am going to do, I will be just saving this data set in a TXT format and that TXT format will look like this. You can see this all the data that we have just created from the ChatGPT. Now this data set we will be using for training our custom NER model. So this will be always be your first step. Next we can see what I am going to do. I am just logging into my Hugging Face account. So for that purpose, I have created the credential in Hugging Face and saved it in a Google Secrets. And now with the help of Google Colab import user data function, I am just authenticating the credential. Second, here we can see from Hugging Face Hub, I am importing the login function. Now this user data function will retrieve the Hugging Face token. If we have successfully login, it will print successfully login into Hugging Face, else it will print Hugging Face token not found in your Colab secrets variable. So let me run this out. You can see it has been successfully logged into our Hugging Face account. The next step is to install all the necessary libraries. So for accessing the datasets or creating the datasets, I am installing this dataset library. So UV is a package manager, then pip install -q basically means we are downloading the dataset in quiet mode and here we are downloading it out. Next, for evaluating the things, I am just going to use evaluate library. Let me run this out. Next, what I am going to do, I will be importing all the necessary libraries. So first of all, by PyTorch library, and from transformer package, I am going to import our BERT tokenizer and BERT token for classification. After that, for training the model, I am importing the trainer and trainer argument library. Then here we can see load data set, after that matrix loading, then again data set, then here train test split function, and finally from this utils package, I am just going to load data function and tokenize and align label function. We will be going to understand what this function actually do in this later part of the code. You can see the weights are getting downloaded here. Next, what I am going to do, I will be loading my tokenizer. So here BERT tokenizer first, and from this I am loading BERT base uncased model. After that, I am defining my target labels. So O means no activity at all. Here activity, I means activity, here then product and then product. These are the labels we have. Now what I will be going to do, each label will be converted into an integer format like label encoding, if you remember, like red, green, blue. Red is given as 1, green is 2, blue is 3. Similarly, if you want to decode this out, I have created another function which is called as id2 label. which will basically decode it out. Like 1 is representing red, 2 representing green, third representing yellow, let us say. Now our data set we have already created. Next, I will load my sentences as well as label from this our data set that I have just shown you, custom NER data set. So here we can see this is my sentences, money, and this is basically the label, which is BO. BO means no activity at all. Here transfer, you can see it is written B activity. Once we have loaded our sentence and label, let me run this out. Here we can see all the sentences. Similarly, this is our labels, you can see. Basically labels are in label encoding format, that's why you are seeing it like this. Now what I will do, I will split the data set into training and validation in the ratio of 80 and 20. So for that purpose you can see I am using train test split function, like input features, target label, and the data set size is 20% and the random state is 42. Now what I will be going to do, I will be converting my data set into Hugging Face format. So for that purpose I am using the data set that we have imported earlier. So data set from dictionary, all the training sentences will be treated as token, then we have the labels. Same for validation data set also. Now we will be understanding what is tokenize and align label function do. If you remember, here in the utils.py, I have created this function, right? Tokenize and align labels. Let us understand what this function will do here. So first of all, you can see we have the sentences like C opened a credit card account, then full stop. What I will do, I will just encode it out. Let us say these are the corresponding label. Now we are use label mapping like this 3 activity, activity and product activity, and we will map it out. Next, in the starting, we have written a CLS token, and in the last, I have added the separator token. And CLS and separator will be treated as none. Rest everything is the label encoded. Now you can see word IDs is this, original label is this, and when we align label will look something like this. Like none will be represented as -100. Rest everything will be same as original label. Now here we can see what I will do. I will just apply this function on our training and validation data set. So I'm using training data set dot map function, then lambda. On each of the examples, I will tokenize and align the labels. This is my token and this is my corresponding label. And batched equal to true basically means we will be doing the batching. Now we will load our pre-trained model. So here we can see I am loading my pre-trained model, which is bird for token classification, and the model is bird base uncached. If you see the number of labels are, these are the labels we have 0, 1, 2, 3. Okay, here we can see label list is not defined. So what I can do, I can just run the above function that I forgot to run, this one. And we can see our pre-trained model is now loaded. Now what I need to do, I am disabling my tracking matrix. Basically, if you want to track anything, we use some library. Here we are using weight and biases. So currently I am disabling it. I don't want to trace anything. So I will just set os.environment weight and biases disabled, which is set to true. Now I will specifying all my training arguments like where I want to store my results. So I want to store my results in NER_results folder. I want to do the evaluation. Evaluation will happen after every 100 steps. We are saving the steps after every 100 steps. Then we have learning rate. So learning rate is 2e minus 5. Basically here we are choosing a low learning rate. There is a rule for it. If you have a very high learning rate, it will overfit And if you have very low learning rate, it will underfit. Here we are using an optimal learning rate, let us say 2e minus 5. Then training batch size is 16, like 16 things at a time. Similarly, evaluation batch size is also 16. Total number of epochs is 30, and after every we have a weight decay of 0.01. Then all the loggings will be in log folder, and every logging will be happening after every 10 step. After this, what we will do, we will call the trainer function, and here we can see model, arguments, training and validation data, and then it will train the model. You can see it is started training the things. Now training will take some time, approximately 10 seconds here. So we can see there are 30 steps and it is giving me the result. Once we have trained our model, now what we will do, we will save our pre-trained result. So here we can see I am saving my model pre-trained, then tokenizer pre-trained, and that's it. Next, I will load my pre-trained model and I will try to make the prediction. So here I am loading my model, loading my tokenizer as well as the model, and checking whether the GPU is available or not, and moving everything into the GPU. Once it is done, I will going to make the prediction. So for that, I am going to create a custom function like predict_ner, which will take the sentence. Here we have the tokens, and we will get our model prediction. After that, it will make the prediction and it will convert the token level prediction into a readable format. Now let us see. This is an example, like my known account is still not approved and funded. So when I try to predict it out, you can see what is happening here. My 0 means no activity at all. Loan is a product, account is a product. Similarly, approved is an activity, funded is an activity. So this is how you can basically make the prediction. Once the things are done, now what we will do, you will push this pre-trained model into the Hugging Face repository. How should we do that? Let me go to my Hugging Face account. Here we can see I am just installing this libraries like Accelerate and Hugging Face Hub. Accelerate basically speed up the training process. Now these are the libraries: bird tokenizer fast, bird token classification. This is our model directory, and this is our mapping that I have written here, like encoding mapping and decoding mapping. Then I will load my tokenizer as well as model as well as the mappings also, and total how many number of labels are there. After that, I will run this out. Once it is done, next what I will do, I will just specify my repository name. So how do you do that? You just go here, click on here, click on new model, create some model. Let us say you created some model like DB. So your repository name will be avi0072/ this is my repository name, custom NER financial bird. Then I will try to log in. Here we can see if it is not exist, it will create the repo. Otherwise, if it is exist, we will leave as it is. Then I will upload everything like all these details, custom NER bot. I will upload this everything. So let me here. You can see repo is already created. You just have to upload it out. It is taking some time because it is around 436 MB here. And we can see it is now uploaded. Similarly, what we can do, we can upload our dataset also. So if you go here, click on here, you can see plus new dataset. So here, I am going to create a dataset repository like custom NER dataset, set it to false, and here I will create repo and I will create the dataset repository function. You can see it is already created. Now what I will do, I will upload this code, basically this code, custom NER dataset.txt. So I'll upload this file to the repository. So this is the whole application Basically, this is the whole project that we are creating. Now, if you go here, you can see that out. This is my repository. You can see I have created this custom NER financial bot. Similarly, in the dataset section, I have also created this repository. So this is how you can perform custom named entity recognition using the Hugging Face library. I will be giving all you the codes and everything in the description, which you can check it out.